To determine the possible numbers of positive and negative real zeros, we use something called Descartes' rule of signs. And that says that the number of positive real zeros is equal to the number of sign changes of f of x, meaning that as we move from one term to the next, do we change from a positive to a negative or a negative to positive? If we do, then that counts as a sign change. Or, so it's either equal to the number of sign changes or less than that by an even number. So we basically count down by twos. So, for example, if we had 7 sign changes in our function, there would either be 7 or 5 or 3 or 1 positive real zeros. So for this particular function, our first term is positive, then we go to negative, so that's 1 sign change. Then we go to a positive term, so that's 2 sign changes. And then to a negative, so that's 3 sign changes. And to a positive, that's 4 sign changes. So for this example, we have 4 sign changes of f of x. So there are either 4 or 2 or 0 positive real zeros. So we start with that 4 and basically just keep subtracting 2 until we either get down to 0 or 1. And Descartes' rule of signs also tells us about the number of negative real zeros, and it's very similar. The only difference is that we're looking at sign changes of f of negative x. So we need to go through our original function and replace x with negative x and count up the sign changes. So otherwise it's the same type of situation as the positive case. The number of negative real zeros is either equal to the number of sign changes of f of negative x or less than that by an even number. So continue to subtract by 2. And the reason for having to go down by even numbers is that if there are any complex zeros, or in other words non-real zeros, those always occur in pairs. Those always occur in conjugate pairs. So because those occur in pairs, we have to take off 2 of these real zeros at a time. So to get f of negative x, we go through and replace x with negative x. Now if I do a negative to a 4th power, because that's an even power, it's going to come out to be positive. So it's the same as x to the 4th. In other words, it doesn't change the sign of that term by plugging a negative x in. If I do negative x cubed, a negative cubed is negative, so that is going to change the sign of this term. So it would be plus 14x cubed. So basically any even power is not going to change the sign from the original function. Any odd power is going to change the sign from the original function. So the 71x squared, that's going to stay positive. Squaring the negatives, positive. And then if I replace x with negative x here, that's negative, and so times that negative there would make that a plus 154x. And then we still have the plus 120. So in f of negative x, every single term is positive. Positive to positive to positive to positive to positive. So there are no sign changes. As we go from one term to the next, positive to positive, that's not a change. To positive, no change. To positive, no change. To positive, no change. So there are no sign changes of f of negative x. That means there are no negative real zeros. And so either all 4 of these zeros are positive, or 2 of them are positive and 2 are non-real, or none of them are positive and all 4 are non-real. But there are no negative zeros. So that means if I was actually trying to find these zeros, once I make my list of possible rational zeros, I know that I don't have to check any of those negative numbers because there are no negative real zeros. So I can cut down on some of my work by looking at Descartes' rule of signs.